Welcome back. Today we're gonna talk about a subject which might be a bit complicated at some point, but I had an idea and I'd like to hear some comments about it. Essentially, it's a poor man's approach to surface roughness measurement. So what is surface roughness? Where's my pen? Assuming this is our machine surface here, which has some hills and valleys, obviously, because it's not flat. Even if it looks flat, it's not flat. And some, this is the solid metal underneath. Some applications need a defined surface roughness. So you can buy a surface roughness tester, which is, let's say, not affordable for anyone because they can be quite expensive. And if you buy the really cheap ones, I don't know if they just tell you some phone numbers or whatever. So the idea is actually, rather than measuring a surface roughness, an absolute surface roughness, we're going to compare it. Surface roughness itself is defined in the surface quality, which is essentially the difference between the valleys and the hills. Because you can have a relatively good surface roughness number, but the quality is crap because you got big hills and deep valleys. So the approach is actually, if we have that's what a surface roughness tester does. If we have a stylus which is pulled over this surface with a defined speed, the frequency will tell us the surface roughness, the channel surface roughness, and the amplitude will tell us the surface quality. So we have all the numbers we need. So we need to compare that to something. And there are fairly affordable surface roughness standards around on a big internet auction house, usually. I came across this one on an auction. I didn't know it was in the lot, but I was quite happy about it. This is a surface roughness standard, and it gives you the surface roughness numbers here in micrometers. So if we have something to compare this one with our machine surface, we are in the game. So how are we going to do that? Sounds complicated, I know. The idea I had was, anyone had one of those? Yes, that was a turntable. Why a turntable? Because it's got a stylus. And these thingies are pretty cheap. So I bought myself one of these cheapo stylus cartridges, which I would never use on any of my records. But this thing has a sharp needle. Don't know what it's made of. Certainly not from diamond. But for what are we gonna do? I think it's enough. So all we're gonna do is we pull that over the surface with a defined speed. So the frequency will tell us about the surface roughness, and the amplitude will tell us what the surface quality is. As we have our standard here, we can pull that over it, and this will tell us a noticeable difference on the scope. I'll hold the camera on the scope in a minute. So this is a pretty flat surface. It won't do anything. This produces a noticeable output voltage, and this is significantly more. So the theory works. as long as we can mount that in some sliding device, and I'm thinking about salvaging a floppy disk drive for all the mechanical parts, because they are fairly precise parts, so why not using one of those? And a floppy disk does nothing else than this, so we can move that back and forth, eventually using the internal stepper even, and just pull that with a defined pressure over the surface. And if I take the camera out of the tripod here, I don't know how good that's visible. That is 0.8 micrometers. That was 1.6. That's 3.2. That's 6.3. I'm trying to pull with the same speed, which is a bit difficult, holding the camera and doing the pulling. That's 12.5. That's 25. And that's 50. I think the difference was clearly visible. I've got it on the storage scope as well, but this is an analog storage scope. So do it this way here. So this is 0.8. This is 1.6. This is 3.2. This is 6.3. This is 12.5. And this is 25. I think on this, on the storage scope, it was even better visible what my idea is actually. So we can either compare that visually or build some electronics, but essentially what we need is some rods with some sort of slider which pulls our stylus this way, and some sort of spring or just the weight of the stylus which pulls us down to the surface. We know the speed, so from the speed we can figure out the frequency, and from the frequency we know the roughness, and from the amplitude, this is a stereo one, so we can probably even filter out the noise. I'm thinking about that. At the moment this is all theory, grey theory, rough theory, but I think it's feasible, and I think we can build something for pretty little money. At least I got at least 10, 15 floppy disk drives around, and the only thing you need is basically that Surface standard. But even that, if you have a surface, let's say a cylinder head, which you know, which is factory machined, and you know what the range is, it's probably good enough to compare. So if you do a before and after measurement, so-called measurement with your own device, you got at least an idea where you are. We're not claiming to do absolute measurements here. All I want to do is a comparison between something known and something unknown, which tells me it's better or worse. And I think for most applications, at least in hobby applications, it could be enough. So I hope that wasn't too complicated. I certainly put it on my project pile. I don't know if I'm going on straight away with it. I need to do a couple of other things, but let's call this part 1. There will certainly a part 2, 3, whatever coming. Depends on how far I'm gonna go. I think I do it somehow electronic rather than the scope, but even the scope will tell you okay what it is. I'm thinking about how we're gonna quantified it in electronic form somehow. This is actually a piezo one. I deliberately chosen one of those because they got much higher output voltage than the moving coil ones, so it doesn't pick up that much mains hum. Obviously it needs a shielded cable and everything, but this was just a quick demonstration because I found them and bought them and thought I'm gonna make a quick video about the idea. Maybe some other people have some input on that, and we can come up with a proper solution, which doesn't cost $500 or $800 or euros or pound or whatever currency you have. So that's my idea of a Pullman's approach to surface roughness measurement. Any ideas, comments, very welcome. I'd like to bring that project forward. At the moment this is just an idea, and what I literally did was just unpacking that and trying it on my surface roughness standard to see if the idea works, and apparently it does, so I think we can go from there. So hopefully we're gonna have some more ideas and a little bit of input for part 2. Thanks for watching. See you next time.